the kite has a number of equal sides. This side here is equal to this side in length, and this side is equal to this side in length. These blue lines are called the diagonals. The diagonals of a kite meet at 90 degrees. So we have 4 right angles in there. This angle is the same as this angle. This angle is the same as this angle. These 2 angles are the same, and these 2 are the same. Now, why is that? Because this diagonal here is also a line of symmetry. So the left and right hand sides of the kite are exactly the same. What we want to do is to work out a formula for the area of the kite. Well, if I take this part here and move it to here, and if I take this part here and move it over here, what I have then is that's the wrong spot. What I have then is a rectangle. Now, this here is one of the diagonals. That's the original width of the kite. We could call that diagonal 1. And this here is the height of the kite. That's also a diagonal. We could call that diagonal 2. Now, so we started off with a kite and we ended up with a rectangle. The area of the rectangle is this distance here. So that's call that the length or the breadth. And that's a half of diagonal 1. So it's this distance here multiplied by this distance here. I hope you can see that. So this distance, half of diagonal 1, multiplied by this distance here, which is diagonal 2. So to get the area of a kite, we multiply the 2 diagonals together and divide by 2. A rhombus is a special type of kite. It's a kite which has 4 equal sides. The diagonals of the rhombus meet at 90 degrees, and there are 2 lines of symmetry. So this is a line of symmetry here. We've got a horizontal line of symmetry, and we also have a vertical line of symmetry. So these angles are the same because we have a vertical line of symmetry, but because the top half of the shape can fold over the bottom half of the shape, these angles are the same size as the ones above. And similarly for these 2 here, let me mark those with an arc. So that angle is the same as this angle because we have a vertical line of symmetry, and this angle is the same as this angle because we have a horizontal line of symmetry. Now, we talked about the different diagonals. So here is the shorter diagonal, we call that D1. And here is the longer diagonal. And we call that D2. And the formula for rhombus is exactly the same. So the formula for the area of a rhombus is exactly the same as that for the area of a kite. So we multiply the 2 diagonals together, and then half the answer. So example 1, we've got a kite here. We want to work out the area of this kite. We're given different dimensions. So what we want to do is to work out the length of both diagonals. So we want the distance from one side to the other. Now we can see that this distance here is 5 centimeters. Because the kite has a vertical line of symmetry, what we can say is that this must be 5 centimeters as well. So the distance from one side of the kite to the other, one of the diagonal lengths, is 10 centimeters. And how long is the other diagonal? Well, it's this distance here from top to bottom that we're trying to find. Well, this part here is 6 centimeters and this part here is 10 centimeters. So the total distance, total length of this second diagonal is 16 centimeters. So the area then, it's diagonal 1 times diagonal 2 over 2. So that's 10 times 16 over 2, and that gives us 80 centimeters squared. Now example 2, I hope you can see that we have a rhombus here. All 4 sides are the same length, so we have 2 axes of symmetry. Now we already know the length of one of the diagonals, that's 20 centimeters. We don't need to do anything with that just now. That's the distance from one side to the other across its widest point. What we also want to know is this distance here, the length of the longer diagonal. And I hope you can see that this 12 meters represents half of that long diagonal. So from this point to this point is 12. So from this point to this point then it must be 24. So D1 is 20 meters. That's the smaller diagonal, and D2, the longer diagonal, is 2 times 12, and that's 24 meters. And the area is found by multiplying the diagonals together and then dividing by 2. So 20 times 24 divided by 2. How would we do that on our calculator or in our head? Well, what we could do is we could half the 20 to give us 10. 10 times 24 is 240 meters squared. Remember the units squared for area. Now the second part of this lesson involves the shape known as the trapezium. It's a quadrilateral like the kite and the rhombus, which is to say it has 4 sides. And it looks like this here. What we can say about the trapezium is that it has one pair of parallel sides. The top and the bottom, in this case, are parallel. And we can't see anything more about it. There is a formula for the area of the trapezium. So I'm going to call this A. I'm going to call this side B here. And the last thing I'm going to do is to mark in the height of the shape. And the formula for the area of a trapezium is 1/2 of the height multiplied by A plus B. Now I could derive that formula for you, but I'm not going to do so. That's the formula that we're going to use to work out the area. Example 1 then. We want to work out the area of this shape. So nice and simple. The formula is area equals 1/2 of the height multiplied by A plus B, where A and B are the lengths of the parallel sides. So this would be A here, and this will be B. So 1/2 of 10 multiplied by 15 plus 20. 1/2 of 10 is 5, and 15 plus 20 is 35, and 5 times 35, 5 times 30 is 150, plus 25 is 175 meters squared. Second and final example, what we have here is a composite shape. I hope you can see that shape 1 is a rectangle and shape 2 is a trapezium. So let's deal with the rectangle first. Area 1, the formula is length times breadth. That should be simple enough. It's going to be 36 multiplied by 12. 36 times 12. Now, without a calculator, 10 times 36 is 360. 2 times 36 is 72. And that gives us 432 millimeters squared. Area 2. Now the formula for the area of a trapezium is 1/2 of the height multiplied by A plus B, where A plus B, A and B are the parallel sides. So let's just check. Here's the height here. That would be A. That's one of the parallel sides. I could just mark in an arrow. And the other parallel side is this one here, which is 36. So that should be simple enough. 1/2 of H, which is 8, times 10 plus 36. 4 times 46. 4 times 40 is 160. Plus 24 gives us 184 millimeters squared. And the total area is found by adding both together. So 432 plus 184. 4 and 2 is 6. 8 and 3 is 11. Put down 1, carry 1. 4 and 2 is 6.